Okay, let's do a quick revision of the last class. Did you all watch it online? Those of you who were absent? There was no video. Okay. So we'll just do a rough revision of what we had done in the last class. Okay, so that you remember. We had done about the structure of the sun. Remember, I asked you what is the sun? Uske pehle ke class pe, okay, let me just clarify first. What language is good? English and Assamese? No, English and Hindi. Assamese. So from time to time, any struggle that you have, if there's something I said, any word that I use that you don't understand, you can ask me. Please laj nokoriba. Kiba eta jodi buji nai poa, logalog khudi diba. Okay? There's no shame in this classroom. So please feel free to ask anything. So we are doing about the sun's internal structure. We know that the sun is the primary part of our solar system. Okay, all the other planets are revolving around the sun. What is the sun? Star. Yes, okay. The sun itself is a very large star. Oh, you have to tell so last class okay, so the sun is a very large star. Why does it appear to be so large? Because let's see the others try. Sun to dekhile kyo iman dangor jen lage amak. Okay, that's one of the main reasons. Obviously, anything that's nearer to you will appear bigger, right? But another reason is also because the sun is in itself a very huge star. Okay, that it's really tiny, but it looks big. No, it's actually a very big star. Okay, but it forms about 10% of the top stars, right? 10%. Tate amar sun to he 10% oda hai. Compared in the size, jodi ami size wise law top 10 on amar sun to ahibo, okay, in the galaxy. Okay, remember how many earths can it accommodate? Do you remember? Kimanta earth, kiman dangor amar sun to roughly? I had told you how many earths can it accommodate? Okay, the sun is so big that it can actually accommodate about 1 million Earths inside of it. Habibo parane 1 million ta amar planets sunor bhitor ami humabo paro. That's how big the sun actually is. Okay, how was the sun formed? It's formed like any other star. Okay, like how the other stars were formed. What is the base? Kihere arambho hoy? Every star? Nebula. Okay, nebula boli ko. What is nebula? Very good. Okay, it's a cloud of gas and dust. Dekhile lage it's a cloud, okay? But it's comprising of what? Gas and dust. So over time, what happens? Remember, one of the suggestions, it's an assumption actually, it's not absolutely proven. But one of the suggestions is that the sun was formed because of shock waves triggered from a nearby supernova. What is supernova? Supernova? Yeah, correct. Okay, whenever a star has crossed the Chandrasekhar limit, that means its mass is extremely huge. It's a very big star, and so eventually what happens? It goes through a massive explosion. When the sun has reached its limit, okay, it's aged. This happens to older stars. Remember always, supernova due to explosion, it doesn't happen to young stars. It happens to stars that have aged, okay, over time. So perhaps there was a supernova explosion nearby, okay, near our sun. And that, the effect of that, obviously, when imagine a star explodes, right? Won't energy be released? Naturally, any explosion causes an effect. Shock waves ahibone nai. Jodi God forbid kobat bomb phate, yate tumi feel koriba no? Eta jhatka eta. So similarly, that's what happens in our galaxy. Some star, we don't know which star, it's an assumption, remember? It's a guesswork. Might have gone through a supernova explosion, and that had an impact on our sun, okay, causing that nebula, all the material in that nebula to start shaking, okay, and then eventually what happens, because of gravity, it begins to come together over time. Lahe, hey, dust particles, okay, they begin to come together, and what is formed? Something called the proto-sun. That's the base, the first step of the formation of our sun. Like how generally star kotha kole ami ki kom proto star, right? So now when we're talking about the sun, it's a proto-sun. And then again, over time, what happens? It gets denser and hotter, more material, more dust particles come together. Nuclear fusion hoy. Nuclear fusion or ki hoy, remember? I had told you what is formed first. Hydrogen is formed, and then this should, like Abhi, that's what I told you. You should sleep and answer these questions now. These are so simple. Okay, hydrogen gets fused, and we are finally getting a heavier element, which is helium. Remember, inside the sun, do we have ordinary particles? Charged particles. Okay, we have charged particles. What causes it to get charged? Why is it charged? Yeah, okay, all of that is correct. Nuclear fusion hota hai, gets separated from electron, but what causes all this? Very basic. I'm talking about the core of the sun right now. So what is there? Extreme heat. It's a superheated ball, this core. And this extreme heat causes the particles inside to get charged, okay? And the electron becomes an independent electron, okay? And then over time, what happens? If something is hot, remember, hot air ki hoy? Hot air rises. And because of that, what is happening? Whatever is inside this, where is it going to go? It's going to go to the outer layer. Okay, it's going to go to the outer layers of the sun. So what are the two factors that cause this? Very good. Solar rotation and convection. Okay, solar rotation, convection hota hai. The basic principle of hot air rising up, cool air coming down naturally because it's denser. When something is colder, it's denser. If you forget this, just remember the example of an ice cube. Okay, the more you heat it up, the molecules begin to spread. It becomes less dense. Eventually, the density drops below air, the density of air, and it rises up, right? So, vapor, water vapor bani jai. So that's the principle, okay? And then remember, some of the material, not all of the material comes in together. Some of it is left behind. The dust particles, some of the gas. So they form something called a protoplanetary disk. And it's because of what? It's because of the gravity that the sun has, okay? That all the dust particles continue to revolve around the sun, forming a disk-like matter. Okay, it looks something like a disk. Okay, all of these facts, not going into this anymore. Okay, these are all facts, nothing much. You remember this, right? From the core, it begins to move out to the radioactive zone. Core or next level to ki hobo? Radioactive zone. Radioactive zone or beyond that, what do we have? The convection zone. Okay, so these are the layers of the sun, the inner layers. Then we have the outer layers of the sun, which you can also call the atmosphere, right? This is like the atmosphere of the sun. So we have the photosphere, chromosphere, transition region, and the outermost region is called what? Corona. Okay. Now what happens? Remember, because these are charged particles, always remember, sun or bhitor or pra, core or pra ki ulai goye se. Not just ordinary particles, but these are charged particles. This is what we call plasma. Okay, monot koriba, the charged you can call it like a charged soup of gas. Okay, inside the sun, you can call it plasma. So this plasma begins to rise up. Okay, so it begins to rise up. And then finally, along with the plasma, what was the best friend of plasma? I told you these two always go together. Charged particles ke saath, what is always there? Correct. There'll always be a magnetic field. What is magnetic field? An invisible force. Jitiao ki beta bostu charge thake like a magnet, a chumbak, right? Jodi ma majot rakhi diu, it's going to begin to attract all the iron materials towards it, right? So that's the magnetic field, an invisible force around it. So because the plasma is charged, it has a magnetic field. So when the plasma is rising up from the core, okol plasma uthi joa nai. It's not just that the plasma is rising up, it's also the magnetic field. But remember the magnetic field sometimes, now remember, we imagine the plasma has reached the core. Okay, it's reached the core. Now what's going to happen? Density is higher or lower? Huh? Lower hoga ki badhega? Think about it. It's reached up, temperatures are cooling now, right? As you're moving from the core. Yes, density will be lower because naturally it's cooler. After that, what happens when density is higher? Will something sink or rise up? Density মানে just imagine it's like the weight. So কিবা এটা বস্তু এতিয়া weight বাঢ়ি গৈছে, solidify কৰি গৈ আছে আকৌ, বুজিছা? Because it's becoming cold, right? So what's happening? All the molecules are coming back together. It's getting denser. It's getting more packed. So what's going to happen to the plasma? ওপৰতে থাকিব নে নামি আহিব? নামি আহিব, right? It begins to sink down. The whole process starts again, and all of the plasma tries to come back ultimately to the core. But electromagnetic fields, juntu asami, because the invisible force of these charged particles sometimes does not allow the plasma to sink back in. So what happens? Do you remember? We had done sunspots. Sunspots? What? Oh my goodness. What is this? Sunspots? Ki hoy to? What forms a sunspot? These are dark patches on the surface of the sun, on the corona. Right? So what causes the sunspot to be formed? Kya hai dark patch sun? Hmm. Hmm. Okay, so basically the plasma has cooled down. Okay, so bhitorat aru fusion hoi thaka nai. There's no activity happening. It's no longer active, right? So if there's no heat, there's no light also, and it's going to cool down on the surface of the sun. What is not allowing the plasma to come back to the core? Magnetic disturbance. You can call it magnetic disturbance. So these magnetic fields, they are invisible, but they have a lot of force. So kabhi, I had explained in the last class, you can imagine magnetic force to be like a spring, right? So when you can compress it together, spring eta eneke dhori thakile ki hoy? If I can compress it, right? It's organized. The minute my duta tinta spring ekelege eri diu, if I release 4 to 5 springs together, for whatever reason, right? Some of them are going to get entangled, some might break. That's exactly what happens with magnetic fields. So we call this magnetic disturbance. So kitiyaba magnetic disturbance hole, sometimes when there's magnetic disturbance, what happens is the plasma is not allowed to sink back in. And so some of it cools down in the surface of the corona. And because it cools down at the surface of the corona is what? The outermost layer of the sun. It forms these dark patches. And these sunspots may be temporary, they may fade over time also. Okay, so they may not always last. Remember, I had also explained something called little torch. Okay, what is this? Ki hoy to? Faculae, little torch, correct. Ki hoy? Okay, both of you are getting it, correct. Go on. It's a very unique thing that happens. Yeah, say. It's a very unique phenomenon that around a sunspot, right? All of your, some of the plasma gets accumulated. And there's also a very strong magnetic field around the sunspots. So, junkhini active plasma thake, sunspot bahirot accumulate ho jay. And because they are still active plasma, they're still charged, nuclear activity is still happening inside. And so they continue to emit light. And because they emit light, they are called faculae, by little torch. And they emit so much light that it's enough to combat a sunspot. Sunspot dark kori diye, kintu faculae light ani diye. So that finally go to a balance with it. Understand what I'm saying, right? So there's an equal balance, and that's why you see the sun shining despite the fact that there are sunspots. Okay, that's a little torch, or also called faculae. Energy flow, okay, all this is fine. Convection zone, core. Just doing a revision for those who are here for the first time today. Okay, these are all layers of the sun's atmosphere. and these are almost, they become invisible. You have to understand these layers, right? These are a continuation of corona. Basically, ki hoy, the more the particles become dense, they begin to sink back in. Only the remaining, which is still hot, right? Lesser and lesser particles continue to vaporize, or they continue to rise up. So the layers keep getting thinner and thinner. And so ultimately, ki hoy, when you finally reach the topmost layer, it becomes absolutely invisible. Okay? हाँ हाँ क्या प्लाज्मा एक्टिव रहता है इसमें, एक्टिव रहता है नहीं, सॉलिडिफाई नहीं, गैसियस में रहता है, गैसियस में रहता है, बट इट्स चार्ज्ड. Yeah, inside the core it's also, it remains a solid, there's a solid mass inside, but then jitna heat badhega, then that solid mass will begin to vaporize also. Okay, it's all solid obviously in the core. Then jab heat बढ़ता है, density will begin to decrease because of the heat, and then obviously जब तक ऊपर layer में चला जाता है पूरा gaseous हो जाता है. You understand? And that's why you don't see it. Similar to the earth, right? Core में solid है. There are solid landmass, there's metals, सब कुछ core में है because it's heavy material, right? Heavy density का होता है, so it sinks. उसके बाद heat है ना अंदर, activity चलते रहता है, friction होता है, fusion होता है. So what happens after that? When there's heat, remember the state of the matter will change, जो basic है. So after that, it will eventually, जब ये outermost layer में पहुंच जाता है sun का, it becomes gaseous. Why? Because it's reached the highest मतलब lowest density है ना, इसीलिए इतने ऊपर तक पहुंचा है. Do you understand what I'm saying? अगर high density होता, it would have been in a solid state, it would sink back. So outer layer में हमेशा gaseous state में रहेगा, because it's less density. That's why it can hold it in the outer layer. And the minute it cools, it becomes heavy, फिर solidify करने लगता है, again it will begin to gradually sink down. ये cycle चलते रहता है एक star के पूरे life span. Okay, so that's why we call it the atmosphere. जैसे कि हमारा atmosphere, right? Can you see it? You can't see it, but there are dust particles. There is gas even in our atmosphere. You can't see it. Why? Because density is very low. Okay, density is very low, and so that's why it becomes lesser than air, and so it begins to rise. Our density low hole ki hobo, it's invisible. Why? The molecules are absolutely spread out. Okay, so that's what happens even with the sun. See here, yeah, the plasma is in gaseous state. यहाँ पे. Okay. In the core, this is where you'll find the more dense material. That heat के वजह से, that's why it's able to go out. अगर solid state में रहता है, it cannot move out. Understand? The heat causes the molecules to expand. Density कम हो जाता है, gaseous form में आ जाता है, and the plasma begins to move out to other layers. So by the time it's reached the top layer of the sun, atmosphere of the sun, पूरा invisible gaseous state में है, कुछ दिखता ही नहीं है. It almost feels like it's non-existent, but it's there. Okay. Okay, this one, sunspots, dark centers, umbra, penumbra is the lighter surrounding area. Sun's corona, solar flares, sudden bursts of energy from the sun's surface due to magnetic disturbance. And what was the larger, if a solar flare is a smaller intensity, larger intensity, what was it? Remember? Yes, coronal mass ejection, CME. Okay? It's basically like an explosion because of the magnetic fields. Certain solar particles begin to get exploded, okay? Or they. Okay. Now, this is also very important. In the after the outermost layer of the sun's atmosphere, certain amount of the charged particles are still moving. Of course, their density is very less, obviously because gaseous state or ase. So, but particles ase. Our particles ase mane magnetic field is also there. So there is that force, invisible force around it. So after you have crossed the topmost layer of the sun, what you will feel is something called the solar wind. It's nothing but an extension of the layers of the sun. But it's just that patol hoy go aise layer ko. Kyo? Density komi go aise. Okay? But the magnetic field is still there. So force eta ase. you'll still feel an impact, but that the impact, you can't call it a layer per se. You feel it like a wind. It's invisible, but it's a force. So you call that solar wind. You'll feel that at the extreme, ekdom sun or layers, ultimate layers bro, outside of the sun's atmospheres, beyond. You'll have to understand. Particles বোৰ থাকে, কিন্তু কমি কমি গৈ থাকে. With every layer, these particles keep reducing. It's there. The magnetic field is also there, but the intensity reduces. Okay? And so by the time you've hit the outermost layer of the sun, you'll feel it only like wind. And so that's what you call solar wind. Stream of hot charged particles, see, they still remain charged, flowing out from the sun, travels at incredibly high speed, okay, 900 kilometers per second. Again, this, even the solar wind, look, is made of plasma. This means the atoms are in the solar wind are also superheated, causing them to split into charged particles, the sun's outer atmosphere. So remember, solar winds originate in the corona, the outermost layer of the sun, but তাৰ বাহিৰত যেতিয়া আৰু beyond গৈ থাকিব, right? Convection keeps happening, solar rotation continues to happen. ये process चलते रहता है. So not all of it is going to come down. Some of it, because of the heat still remaining, they continue to rise up. But my हेतु so particles keep reducing in number. In magnetic field keeps reducing. So impact also reduces. So by the time you've hit beyond corona, you've gone to the outermost layer, you only feel it like wind. But of course, that wind is a very strong wind. এতিয়া মই এনে casually কৈ আছো solar wind, but the impact of it is huge. Okay? And then remember this, some of the solar particles, most of it does not enter the earth usually. Okay, the light is absorbed by our own atmosphere, and the particles are thrown back out into the interstellar space by our Earth's magnetic field. Earth ka bhi ek magnetic field hai. We also have our own same charged particles, everything. So some of the particles that come towards the earth from the sun, it's not taken in, right? We push it back into space. But in certain unique conditions, it falls into the earth. It sort of enters the earth's atmosphere. And so when that happens, we see it appear something like this. Something that you call northern lights. Okay, it's known as northern lights. It's nothing but charged plasma that has managed to enter the earth's atmosphere. Okay? And so it looks like this. Very unique.
Why is it seen only near the poles?
Why is it seen only near the poles? It's because of the magnetic field. Magnetic field. It's the Earth's magnetic field that will allow the solar particles to enter. Magnetic field पूरे Earth में same नहीं होता. It's only stronger towards the poles. Because of which it will allow these particles to even enter in. Okay, see, these particles crash into, okay, blah, blah. Charged particles from the sun get pulled in by the Earth's magnetic field. So wherever the magnetic fields are like extremely strong, they'll attract it inside rather than pushing it back. Okay. Usually, the magnetic field is not the same, not evenly distributed throughout the earth. So it's stronger towards the poles for whatever reason. Okay. And uske wajah se the solar particles get attracted, pulled in by the magnetic field. And it creates this beautiful greenish glow in the sky, which is nothing but, now you know it's plasma. Okay, or it's your solar particles. Okay, that's it from here. So today we'll do a very short chapter. What is this? ये वाला है ना? Play. Okay. This is a very simple topic. Oh, okay. Oh, autoplay कर दिया मैंने. Brilliant. Okay. Now remember when we have talked about the origin of the solar system? It all started with what? Huh? हाँ dust, but क्या मतलब शुरुआत किससे हुई थी? What caused it all to come into existence according to science? What is the theory? Why? Okay, so it all starts with Big Bang, right? Imagine everything starts with a tiny ball or a singular atom with infinite density, infinite temperature, okay, infinite pressure building up on the inside. One fine day, it explodes, right? And so all that comes out of it is infinite amount of gas and dust particles. Gradually, accretion hota hai. You remember the word accretion? What was accretion?
Gathering of particles.
Correct. Okay. So over time, what happens? These particles begin to come together, forming masses. Okay, solidified masses or gaseous matter. And so usse nikalta hai your stars, planets, all of that is formed. But for some reason, like I had mentioned in the last class, not all of it comes together. Some of it is left. Okay, বুজি পাইছানে গোটেইখিনি গোট নাখায় কিছুমান ডাষ্ট পাৰ্টিকলছ থাকি যায় সলিডিফাই কৰে কিন্তু প্লেনেট বা ষ্টাৰৰ পাৰ্ট নহয় they remain as singular rocky material or icy matter and those are what we end up calling asteroids. Okay, so this is nothing but these are leftovers. Okay, somehow they were not chosen to be a part of planets and sun for some stars. For some odd reason, they are left out. And so these are nothing but leftovers from when the solar system was formed. After the Big Bang happens, all of it maximum end up forming planets and stars. Some of it is left behind. That left behind matter is what you would end up calling asteroids. Mostly found in a ring. This is important. ये आएगा MCQ में. Where do you find this asteroid belt? So mostly it is found between Mars and Jupiter. Okay, so between Mars and Jupiter, there's something that we call the asteroid belt. All the asteroids sort of accumulate together, forming a belt. So you call that the asteroid belt. It didn't form into a planet because Jupiter's gravity kept them scattered. Okay, Jupiter has very strong gravity because of which it does not allow these particles to move and come together. They remain as singular particles. Now this is important. Mainly rock and metal. Some have ice, also called planetoids by scientists. Why do you think these are mainly rock and metal? Look at their position. They are between Mars and Jupiter. Why do you think they are rocky, metallic? You understand their position of asteroids? Yeah. What is happening? Here, look. Mars, Jupiter, and iske beech mein you have the asteroid belt. And this is the largest asteroid, Ceres. Okay, this is the largest in the belt. Ye wala. Ceres the exception, the biggest asteroid, 946 kilometers across. So why do you think this is rocky and metallic? Correct. It's the same reason why these inner planets are rocky. Remember that? The terrestrial planets, the inner planets are rocky and not gaseous. Why? बोला एक तो बोला सही बोला solar wind. Okay, remember solar wind is what? These charged solar particles that are here in the beyond the corona. Corona ke bahar chale jane se they are felt as solar wind, and because they are charged, they have a magnetic field, so they have an invisible force around it. So the nearer you are to the sun, right, sun, the stronger you will feel the wind. Now, if there is very strong solar wind, you will not be able to hold the light gases. The light gases get blown off behind because of very strong solar wind. The second reason is also because it is so close to the sun, the gases don't get an opportunity to freeze. They don't freeze. And instead, the gases are pushed behind. And that's why the planets beyond here, okay, these planets behind, these are what you call outer planets. They are gaseous in nature. And because they are far from the sun, what happens? Solar wind or impact is less. And number two, the gases can freeze. Similarly, even here, these asteroids, they are close to the sun. So, solar wind impact is going to be huge. Number two, gases don't get enough temperature. They're not cool enough to be freezing. So, these are rocky in nature. All that's left behind is the rocky, crusty material. The gas around it is pushed behind. And interestingly, when you come behind here, there's another belt of something else. If asteroids are like your tinier, it's pretty simple. Look at it this way. यहाँ पे है rocky, crusty planets. उनके बीच में there are extra रह गए, कुछ बचे कुचे रह गए, which didn't get to join into this planet system, right? So those form asteroids. Behind, what do you have? Icy planets, gaseous planets, planets made of gas and frozen gas. So some of it again, पीछे जाके भी they don't join the outer planets. So they remain as tiny pieces of ice. And those are what you will ultimately end up calling comets. Comets are extremely cold, made of ice, found towards the outer part of the solar system. They are closer to the outer planets, far away from the sun. Okay? Put your phone on silent, please. Let it not ring. Let my phone also not ring. I always have to check my phone when I tell you all, because if my phone rings, you laugh. Acha. So, what is the largest asteroid? This may come. Okay, Ceres. It's the biggest. It's about 946 kilometers across, large enough to be round due to its own gravity. Classified, it can even be a dwarf planet. Ceres. It's so big compared to other asteroids. Okay, in this particular asteroid belt, Mars and Jupiter के बीच में जो asteroid belt है, there Ceres is the largest. Okay, question. Most asteroids orbit the sun in a girdle between Mars and Jupiter. Okay. Asteroids, বুঝি পাইছা নে asteroids কি হয়? হা? পাইছা ন? যোনখিনি particles basically planetত join হৈ নাযায়. ইহঁতি left মানে থাকি যায় ইহঁতি. For some reason single কে এনেকে পাথৰৰ নিচিনা ইহঁতি থাকি যায়. সেইবোৰ যোনবিলাক আমি ইয়াতে সৰু সৰুকে পাওঁ আমি ইয়াতে, these are called asteroids. They should have joined to form planets, কিন্তু ইহঁতি join নকৰে. আৰু ইহঁতি singular particles কে থাকি যায়, matter, rocky matter, and so you call them the asteroid belt. What just happened? क्या हुआ इसको? Does this hang ever? Yes. It hangs, no? अभी ये अच्छा, इसका खुद का ही दिमाग है ये. Operating in a different world. What is this? Where has it gone now? Okay. The group of small pieces of rock revolving around the sun between the orbits of Mars and Jupiter are called asteroids. Consider the following statements regarding asteroids. Read these carefully. Asteroids are rocky debris of varying size orbiting the sun. Most of the asteroids are small, but some have diameters as large and whatever. What is this English also? I don't understand. ये क्या लिखा? 1,000 kilometers. The orbit of asteroids lies between the orbits of Jupiter and Saturn. So which one is right? Which one is wrong? C is number 3 is okay. So this is wrong. Pretty obvious. It's not between Jupiter and Saturn. It's between what? Mars and Jupiter. Okay. Okay. Comets are, look at this now. Asteroids hai rocky, crusty pieces of debris that don't join planets. They are closer to the sun. Okay. In between Mars and Jupiter. Now, when we go towards the outer part of the solar system, further away from the sun, we find comets. Comets are comparatively small. Flimsy matlab kya hai? Have you heard of this word? Flimsy. What does it mean? Anybody? Flimsy means something that's not strong, okay? It's easily breakable. Do you understand what I'm saying? Something that can easily be broken. Suppose a chair, if it's not strong, it's not sturdy. आप बोल सकते हैं ये chair flimsy है. मतलब बैठने से ज़्यादा ये टूट भी सकता है. So anything that's easily breakable, not very strong, you call that flimsy. So comets are comparatively smaller, flimsy, erratically shaped. Have you heard of this word? Erratic? हाँ? ये शब्द? Erratic? हाँ हाँ. क्या होता है इसका मतलब? इरेटिक मतलब क्या? हाँ? Say. You've never heard of the word? हाँ? सीधा, straight? No. Erratic means irregular. Irregular. So these are irregularly shaped, okay? Suppose there's somebody whose opinions keep changing. Use this word erratic. I'm helping you for SSB. थोड़ा smart sound करने के लिए ये सब words use कर लेना वहाँ पे. Okay? Erratically shaped. Erratic मतलब something that keeps changing. Okay? Irregular. कोई fixed shape नहीं है. So comets are usually erratically shaped. No fixed shape. They can keep changing. They are the leftovers from the solar system formation. Comets are icy balls that form in the outer solar system. They have icy and very cold surface entrenched with grit, dust and particles from space. So obviously they are further away from the sun. So naturally you can't expect them to be hot lava या फिर garam ice hot gaseous balls. It's not that. These are icy. Okay, basically the gases have frozen. बुझी पाइছে না? Because যদি temperature low হয় কি হবে? I already told you molecules begin to come together, density increases of a matter and it solidifies, right? So this is exactly what happens in the outermost part of the solar system. You have these leftovers. If they are closer to the sun, they form asteroids. If they are further away from the sun, they form icy matter. And no particular shape can keep on changing. They are erratic. Okay? Several comets have elliptical orbits. Elliptical, you understand the shape. It's almost like oval shaped. They're not round. They're not proper. They are more like an oval shape, this way. Okay, so some of these comets have elliptical orbits. So Halley's comet, we've all heard of it. Arguably the most famous comet. It's a periodic comet. Returns to the Earth's vicinity about every 75 years. This is also important. Halley's comet, कितने साल बाद? Periodic, मतलब after a fixed time period. Have you heard of this word? Vicinity. Vicinity means to come close to something. Okay, so basically, we are saying to the Earth's vicinity, it's coming close to the Earth's surface. So the Halley's comet comes close to the Earth every 75 years. Periodic comet, why? Because regular time periods may you'll see it. So after every 75 years, you wait to see the Halley's comet. So many movies have been made on this, making it possible for a human to see it twice in his or her lifetime. The last time it was here in 1986, and it's projected to return in 2061. So sai thakiba aru. Another how many years? Almost 40 years. Wait to see the Halley's comet. Yeah, but you all will see it. I'll see it. I'm going to be alive, no, 40 years. So sabar Halley's comet. Okay. Now this is the nucleus of the comet. This is where you'll find more of the solid matter. And then because of solar wind, remember when a comet starts moving towards the sun, there is naturally solar wind, right? Surface mein, sun ke surface mein beyond corona, there is solar wind. So whenever you're moving close to the sun, you're going to feel the impact of the wind. Jiman sunor usor jaba himan tumi wind or to effect to hetu feel koriba. So when a comet begins to move towards the sun, you feel the solar wind, right? And so because of the solar wind ki hoy, a nucleus tur pora certain matter begins to fall out and form like a tiny a gaseous circle type form kore outside of the nucleus, which you call the coma. Okay. And remember, the sun's solar wind is charged because it's plasma, right? Sun, everything is charged. Okay, extremely hot, it's always charged. Excited state mein hota hai sab kuch. So whenever particles from the comet begin to collide with the sun's charged solar wind, some of the particles of the comet also get charged, and then it forms something called an iron tail. Okay, comet से the certain amount of particles, एक तो solar wind है, so some particles push out from the nucleus and they form a tail-like structure. But because the solar wind is charged, even the matter यहाँ का जो छोटे-छोटे particles होता है comet का, ये भी charged हो जाते हैं. Okay, and so this is what forms the iron tail. And apart from that, you have the dust tail. Okay, this is also another trail. It's another tail of matter coming out from the nucleus. This, however, is the non-charged matter. For some reason, one portion gets charged, the other remains uncharged, regular neutral dust particles forming a dust tail. And the impact of all of this only happens. The iron tail is only formed when a comet moves towards the sun. Okay, because it requires something to give it charge, right? What will give it that charge? The solar wind. Okay? Solar wind is charged plasma. It has charged particles. Okay, so comet, a mass of ice, rock, and dust drifting in space that often has a tail which grows as it gets closer to the sun. The tail is made up of water, dust, and various gases vaporized by solar energy. Why do you think it grows? Why does the tail grow? The closer I'm moving to the sun, the more my tail is growing. Why? Just, huh? Huh. Correct. Common sense. Okay. So nucleus or good dust particles, it's in a more dense form, right? It's more compact. Now imagine this. How do I explain it? What can I make a ball out of? Can you tell me something with which you can make a ball, and when I put pressure, it breaks into powder? Think of a laddu. Okay, I'll make it easy for you. Think of a laddu. When you're putting force on it, right? What's going to happen? It's beginning to crumble. The more force you put, smaller particles will come out of that laddu. Okay, so imagine the comet to be like a laddu. Okay, it's more solidified, but now there is force coming in. There's pressure coming in from where? The solar wind, right? The closer I'm going to the sun, the stronger the impact of the solar wind, right? It's like now you're close to that AC. You're feeling the wind more. I'm further away, I'm feeling the wind much lesser, right? So similarly, the closer this comet is going to go to the sun, the more intense the solar wind is going to get. Jiman intensity baribo mane ki aru force lagi ase nucleus to upor. So aru particles bhangi go ase. And the more particles break out from the nucleus, the longer, where will they go? They will form the tail. Jiman particles bhangibo, himan digholia tail hoy gothebo. Because the tail is ultimately formed of what? Broken particles that have come out from the nucleus, right? So that is the reason why the closer you go to the sun, the longer the tail is going to get. Then you have asteroid, body made up of rocks, metallic and non-metallic, that orbits the sun. Okay, usually in the asteroid belt between Mars and Jupiter. Some asteroids and some asteroids are comet nuclei also. That means some asteroids are also made up of ice. They are like smaller versions of comets, but they are in that asteroid belt. Okay, they range in size from few centimeters to 1,000 kilometers. Very rarely, but asteroids will look like comet nuclei. Okay, now this is important. Uh, let's explain it this way. What does this look like? So imagine this is a planet, okay, formed by what? Accretion. All of the tiny dust particles, gas particles coming together, forming a bigger structure called the planet. Some of it does not join, right? Some of it don't form stars, they don't form planets. So they are left over here, okay? These are what you call, what are these? Asteroids. If they are in the inner part of the solar system, they are asteroids. If they are towards the outer part of the solar system, near the outer planets, they are comets, right? Now again, because of the force, there's so many forces acting in the solar system, right? There's gravity, there's friction, there's a magnetic field, so many forces acting on particles. So because of those various forces, certain particles from these asteroids can again further break down into smaller pieces. Basically. So when pieces are broken out from either asteroids or comets, okay, usually asteroids, yeah, they form these tiny rocks which you call meteoroid. Okay? Meteoroid, it's nothing but a space rock, a rock in space. That comes out from the breaking of asteroids, comets. Sometimes if pieces of a star also break apart, okay, and they form these tiny rock-like pieces, you call them meteoroid, and you find them floating in space. They are much smaller in size. Okay, they are much smaller in size. So, सबसे डांगर form to होबो maybe a star, নহলে a planet, right? If that does not, if some material is left out, then usually they form asteroids or comets. কিন্তু সেই asteroid, comet বা তোমাৰ planet, star যদি তাৰ পৰা সৰু সৰু পিচ ভাঙি যায় আৰু পাথৰৰ নিচিনা ফৰ্ম হৈ যায়, সৰু পাথৰৰ নিচিনা স্পেচত যেতিয়া আমি বিচাৰি পাওঁ সেইবোৰক আমি কি কওঁ? meteoroid. Okay, they are called meteoroids, tiny pieces of space rock. Now, a meteor is a streak of light we see when a meteoroid enters Earth atmosphere and burns up due to friction. So you know this, right? Whenever there are, like, suppose two pieces of rock, if you take, and if they begin to, if there's friction, you see sparks, right? So similarly, when a meteoroid comes towards Earth, আমাৰো নিজৰ particles আছে, আমাৰ নিজৰ atmosphere, we have our own dust particles, we have our own gas. So there's going to be friction when meteoroids come towards Earth, right? Friction with the particles of our planet. And because of that, you'll see a light that is generated. Friction hole and actually ki hoy, a certain amount of light energy, heat is also released, light is also released. So you see a streak of light that you can see when a meteoroid enters the Earth, primarily because of what? Friction. Okay? And so that streak of light is called the meteor. Meteor is not the rock in itself. It's the streak of light. It's the light that you see when a meteoroid enters the Earth. These three, are a little confusing. They all sound the same. Yeah, meteoroid, meteorite, or meteor. So be a little careful with these three for your multiple choice. So just remember, जब solid state में रहता है like asteroid, तो meteoroid, roid matlab it's in that solid state in space. Okay. Now when that meteoroid, just remember meteoroid is broken out from an asteroid, so it's that rocky, space rock. When it comes to the Earth, the light is called the meteor. Okay. Now when the meteoroid doesn't fully burn up in the air, Okay, some of it explodes in the air. It gets burnt up due to friction. और हमारा खुद का force है. Earth has its own forces, right? So which don't allow a meteoroid to reach the Earth. Otherwise, we'd see meteoroids falling every day. Most of it gets destroyed in our Earth's atmosphere, but some of it manages to reach the Earth's surface. And those that reach the Earth's surface are called meteorite. বুজি নাই পোৱা? So imagine there's a space rock, এটা rock এটা আহিছে outer space ৰ পৰা আহি আছে আমাৰ earthৰ friction আছে আমাৰ নিজৰ এতিয়া okay I'll show it this way. Earth, okay, meteoroid ahi ase full force di pale it's coming towards Earth, right? Earth has its own atmosphere that has its own particles. Ita ei horu particles bor logot ei meteoroid to it's going to clash, right? And there's going to be friction hole ki hoy heat light kitiaba this energy the friction is so strong, mostly it's so strong, right? Iman force ot ahe aru iman friction hoy with our own particles that a meteoroid to ahiye na pai, it gets destroyed in the while in its journey. বুজি পাইছা আহোতে আহোতে এই মেটিঅৰাইটটো পুৰা ভাঙি থাকে সো আহিয়ে নাপায় তোমাৰ আৰ্থলে কিন্তু কিছুমান meteorites they make it to the earth. Okay, maybe the friction wasn't strong enough, for some reason they managed to survive aru ahi pale they reach the earth's surface, and when they reach the earth's surface basically hey meteoroid tore naam bodli jay and you call it a meteorite once it has landed successfully on the earth's surface. All meteoroids don't land on the earth's surface, they get destroyed in space by the atmosphere because of friction they are destroyed with amar nijor particles bro logot. So they don't make it, they get burnt up because of the heat energy, because of the friction it bhangi jay space hote. You know, some of it makes it. So you hear in the news kitiaba meteorite has landed, they found a meteorite kobat pore in some parts of the world. Okay, so easy way to remember this, I'll just tell you. So when it's in outer space, right, it's meteoroid. Just remember asteroid. Okay, uska bhai meteoroid. Okay, then the light is meteor. Simple, hetu mon rahiba. And then this one has done something right in life. Okay, I'm just simplifying it for you. You'll not forget. This meteoroid has done something right in life, which is why it successfully lands on Earth. And so it's a meteorite. ये कोई logic नहीं है, okay? Don't say ये science का है. I'm just teaching you a trick to remember. Okay? So the one that has done something right has landed successfully. It's a meteorite. Right. When it's in space, it's a meteoroid, like an asteroid. And the light that you see when it's coming towards the Earth, that's a meteor. Okay? Ita bujisane? Okay, now some of these some of these meteorites, they may be small in size, right? But because they are falling from an extremely high altitude, okay, very high heights, right? So what do they have? An enormous amount of stored energy. No, যিমান ওপৰৰ পৰা পেলোৱা মই যদি ইয়াৰ পৰা এই পেনটো পেলোৱা ইমান দুখ নাপাওঁ ওপৰৰ পৰা যদি মই মাথাত পৰে এইটো মই বহুত দুখ পাম, right? Because the level of energy, stored energy increases. So similarly, এটা meteorite may be small in size. So hetu jodi moi ene rastat pao hetu iman impact nopore. But because of where it's coming from, it has a lot of stored energy. And so eventually when it's in motion, it's turned into what? Kinetic energy, right? And then when it falls on the earth, because of the energy, it is going to form a huge hole in the earth's surface. Okay, earth ke surface mein it's going to create a hole. You don't call it a hole, okay? It's called a crater. So when a meteorite lands on the Earth's surface, it creates a huge impact. It creates something like a hole-like structure, a dense hole, which you can call a crater. So we have famous meteorite craters in India. These are there: Lonar Lake, Maharashtra; Dhala crater, Madhya Pradesh; Ramgarh crater, Rajasthan. These are important. Okay, where do you find famous craters in India? You can write it down. Lonar Lake, Of course, all this is there on the internet. You can always get a list of craters that you find in India. Okay, there. So it's a meteoroid in outer space. When it's entering the Earth's surface, you can see the streak of light. It's a meteor. Finally, when it's done something right in life, it has landed on the Earth's surface successfully. It has become a meteorite. Okay, I think that's it. I told you it's a short chapter. Anything you didn't understand? It's quite easy, right? Yeah? Asteroids, comets, wala. It's quite simple. There's nothing much. And where have I landed? Where have I come? Can somebody please tell me? Screen share. The whiteboard. Finder. Now I went somewhere else. They're also called planetoids. Remember this. So instead of asteroids, if they give you what are planetoids, don't say yes, syllabus mein tha nahi, we never studied it. Okay? Asteroid is also planetoids. I'll ask you a few questions. Okay. Do you know what is this? The Cooper belt. Okay. कहाँ पे है? Where is it located? Huh? Okay. Near which planet? Okay, near Neptune. What is it made up of? Correct. I see. Okay, because it's far away from the sun. Let's see if there's anything else. Believed to be a remnant of the early solar system's formation and contains valuable clues about history. Okay. Okay. Just ask you two, three questions. First one, give me major differences between asteroids and comets. Yeah, give me major differences. I want the others to say. इस वाले kita हुआ किबा? The ones in front are answering. You all can also answer. Difference between asteroids and comets. Okay, fine. Comets are made up of ice, dust, and asteroids are made up of rocks. Okay, rocks and also metals. Okay, metallic and non-metallic material both. What about the ones behind? Any difference between asteroids and comets? Okay, comets are flimsy, fine. Okay, flimsy means easily breakable. Also there. Anything else? Does comet forms a belt? Comets, yeah, they form a group. They form a belt-like structure. They do. Bolo or bolo about the position. Tell me where. Tell me something about the position. Okay, so the better way of saying it is compared to the sun. Okay, where is their position? Yeah, they form a belt here, right? It's the Cooper belt objects. Yeah. Okay. What else? Comets have elliptical orbits, several of them. Asteroids don't. Okay, asteroids don't have orbits around them. Any other? I'll give you a few definitions. Wait. Okay, when a meteor is coming towards the Earth, I mean a meteoroid, what is it called? When it's coming towards the, okay, they are called meteors. That's the light. And once it has landed successfully on the surface, meteorite. Okay, वो याद रहेगा ना भी right and wrong. So yeah. Okay. It's not much to ask from this. It's quite basic actually. हाँ पूछने लायक कुछ है नहीं. It's quite simple. Okay, some rocky fragments that endure passage through the atmosphere of the Earth and hit the ground is known as meteorites. A meteor is a piece of matter which has entered the Earth's atmosphere from outer space. Yeah. What is the difference between asteroids and comets? Look at this. Asteroids are small rocky planetoids, while comets are formed of frozen gases held together by rocky and metallic material. Asteroids are found mostly between Jupiter and Mars, while comets are found mostly between Venus and Mercury. Comets show a perceptible glowing tail, while asteroids do not. Which of the statements above is correct? Okay, 1 and 3 are correct. Okay, comets show perceptible glowing tail. Perceptible means something that's visible. Okay, जो दिखता है, you can see it. It's called perceptible glowing tail. So the Kuiper belt, it's located beyond Neptune. It's a giant icy version of an asteroid belt. Okay, It's like an asteroid belt, but it's made up of ice. Home to many icy objects, including dwarf planets like Pluto. So they may ask you, where is Pluto located? And you would remember that it's located in the Kuiper belt. Which ones? So ये तो पहले जो आगे में बैठा है. हाँ. Yes. हाँ. अच्छा, ठीक है. Okay, these are some interesting facts. Pluto, the largest known object in the Kuiper belt. Is Pluto still a proper planet? No, right? It's gone now to become a dwarf planet. Used to be considered the ninth planet. In 2006, it was reclassified as a dwarf planet because it meets the other criteria for being a planet. It hasn't cleared the space around its orbit of other objects. Charon, okay, is Pluto's largest moon. So big relative to Pluto that they sometimes orbit each other like a double planet system. It's almost the size of Pluto itself. It's as big. So when they're orbiting around each other, it seems like two planets moving around each other. Okay, that's Charon. Okay, yeah, this is important. What is Goldilocks zone? I forgot that we have this part. The area around a star where the temperature is just right for planets to have liquid water. So it's not too hot, it's not too cold, the temperature is just right for water to be in its liquid state. If it's too further away, it's going to be frozen, right? So it's going to be solid. If it's too close to the core of the sun, right, what's going to happen? It's going to ultimately vaporize. So important for life as we know it because liquid water is essential. It's called Goldilocks. It's called the Goldilocks zone. Remember, that area in a star where the temperature is just right for water to remain liquid. Careful. Okay. The porridge and beds were either too hot, too cold, or just right. The Goldilocks zone is where the temperature is just right for water. This is related to the story Goldilocks. Okay. You have time today, go home and read it. Have any of you read it? Okay, so you can go home and read it. It's a simple fairy tale. Goldilocks zone is where the temperature is just right for water. Earth is a Goldilocks planet. Earth's position in our solar system puts it in the Goldilocks zone. Too close to the sun like Mercury, water would boil away. Too far like Pluto, water would freeze. Very basic. Okay. So thankfully we are just right.
Only Earth is a planet which is in Goldilocks zone.
Yeah, but I mean,
Any other planets?
I mean, now they are figuring out, right, that there may be water in Mars. ये सब तो बोल रहे हैं अभी. So could be still figuring it out. But Earth, I mean, as you know it, we're just right. Okay. That's the whole search, right, to see where else can you find water. ये कुछ नहीं, it's basically just the boundary formed by dust particles because of the solar wind. All the solar wind blows, a certain amount of particles blow out of the sun, forming a boundary-like structure, which you call a heliosphere or a heliopause. It's like the boundary of our solar system. Okay, particles from the sun keep blowing, right? And finally go at a point or they stop and they create like a boundary. The tiny particles that are blown out because of solar wind. And so that's what you'd call the outermost part is the heliosphere is the inner portion and the outer boundary is what you call the heliopause. Heliopause is more like the boundary of our solar system, formed out of the tiny particles that are blown out by the sun over time because of solar wind. What defines the boundary of the solar system? Sun's light, the influence of the sun's gravity, or the influence of the sun's magnetic field and solar wind? Yeah, influence of the sun's magnetic field and solar wind. Correct. Light and gravity from the sun gradually get weaker with distance. They don't have a sudden stopping point. So they basically just merge into outer space. Okay, उसके बाद ये heliopause, it just merges with outer space. There's no like well defined, ऐसा नहीं है कि boundary दिखता है. Okay, you don't see it, but the impact of it can be felt. Solar wind is different. It's a stream of particles from the sun pushes against thin gas and dust between the stars, interstellar medium. This interaction creates a giant bubble around our solar system called the heliosphere. Okay, so basically there's a lot of other interstellar medium, right? There are planets, there are stars. There's not just the sun, right? There are others in our galaxy. They all have their own dust, they all have their own gas. So what happens is material from the sun begins to push with other interstellar particles, and when they do that, what happens, they create like a bubble like structure in our solar system, which is called this your heliosphere. This area is your heliosphere. Right? They're forming a bubble like structure. What's happening? Certain material from the sun begin to interact with the other material of the interstellar system. Okay? And they create a bubble like structure called the heliosphere. Parts of the heliosphere, the outer region of the heliosphere. Okay. The sun moves through space, so the heliosphere isn't a perfect sphere. It forms a shock wave against the interstellar medium like a boat moving through water. Okay, it's not so important here. Uh, okay, these are important. Please take note of these 3 points. Termination shock is that point where the solar wind slows down to below the speed of sound. Okay, it's called termination shock. Okay, so the further away you move from the core of the sun, right? Gradually you're moving further and further and further away. Solar wind's intensity keeps reducing. Okay, and so there comes a point where it slows down so much that it drops below the speed of sound. That point is called termination shock. Heliopause is the very edge of the heliosphere where the solar wind is fully stopped by pressure from the interstellar medium. Okay, so you understand beyond our solar system, there are other celestial bodies. It's not just our sun and our planets, right? We have a huge galaxy and beyond, so much that we don't even know. So there are other celestial bodies or heavenly bodies that have their own pressure to exert. उनका भी है अपना magnetic field, they have their own gravity. So what happens is solar wind keeps reducing, right? As you move further away from the sun, the intensity of that wind, what is that solar wind? It's basically the charged plasma that's becoming lesser and lesser dense, and magnetic field kam hote ja raha hai, and so you feel that force in the form of wind. The lesser the charged particles over, you understand, as you're going further away, it's getting more and more it's becoming gaseous, so the intensity of the wind is reducing. And there comes a point where you've moved further away from the core of the sun, or it's reached the edge of our solar system, or bahar se, from the other stars, from the other celestial bodies, they are also now exerting their own pressure against the sun's solar wind. And because the solar wind is becoming weak, right, because it's moving further from the core, it stops. The solar wind stops at a particular point. And where the solar wind stops, that's considered to be the boundary of our solar system. That our solar system, with our sun and these 8 planets and your asteroids and comets, it ends there, where the solar wind stops. Okay? What causes the solar wind to stop? It is pressure from interstellar medium, from the other celestial bodies that are there in the galaxy. They exert pressure on the solar wind, and solar wind is not strong enough to push through, so it stops. Okay? And then the space between termination shock and heliopause is called the area in between. Not simple, there's nothing. The area in between. The outermost layer of the heliosphere, the edge of the heliosphere, is the heliopause, where basically it's like the solar wind is coming to an end, stops, and the solar system's boundary. It's the heliopause. It's a pause. Pause means what? To stop something, right? So what stops? The solar wind stops at this point. Why? other interstellar medium का pressure आते रहता है. Solar wind reduces its intensity, cannot pass through, the wind stops, right? And so that's when it's the boundary of our solar system is formed. We call it the heliopause. So what is heliopause? Basically, it's the edge of the heliosphere. Heliosphere ka. And what is heliosphere? The bubble-like structure that is formed when solar particles interact with what? Other interstellar medium, other interstellar particles. Okay. Heliosphere. Termination shock. What is termination shock? We did that just now. क्या है ये? Below what? Below speed of sound. Okay. Okay. Here, there's something called the Oort cloud, right? The Oort cloud. So this is basically considered to be a huge sphere, a huge area comprising of icy bodies. Okay, a lot of icy bodies are here, and they are believed to be the source of some of the earlier comets. That yeah, try Oort cloud or bhangi, agole goi, the comets were found. Okay, that's what it's believed to be. Okay. Uh, they are located far beyond the orbit of Pluto. So remember, this is way beyond your Kuiper belt. Okay, Pluto beyond. So basically, it's way beyond the Kuiper belt also. Kuiper belt is near Neptune. Okay, and then beyond Pluto is the Oort cloud. Further away from the sun, it's all frozen, icy bodies you will find over here. It's inferred from the orbits of comets. Okay, and here you find a new star system, this Alpha Centauri star system, closest star system to our solar system. यहाँ से शुरुआत होती है of a new star system here. This is the Alpha Centauri. It's another star system. Okay, that's closest to our solar system. So this may also come. Which star system is closest to the solar system? So the answer to that would be your Alpha Centauri. Just write that down. No, it's a star system. Star system, that means it's basically, you can consider it to be a new galaxy from here. यहाँ से शुरुआत होती है Oort cloud के बाद, closest to our solar system. Another star system starts again. The Alpha Centauri system is of great interest to astronomers and space exploration enthusiasts due to its proximity and the potential for hosting exoplanets. They believe that inside of this, there could be more planets inside of the Alpha Centauri. So, हाँ, galaxy है, उसके अंदर और stars है, और planets भी हो सकते हैं इसके अंदर. So this is of great interest to our scientists because it's closest to our solar system. Okay, Alpha Centauri. It's just, remember, it's a star system. Better you write star system ही बुलाते हैं इसको. They don't exactly use the term galaxies also, even though galaxies are cluster of stars. But यहाँ पे they've used the term star system. Okay, it's the nearest to our solar system. Have you written all this? Termination, shock, heliopause, area in between? Written? Sab likh la? Okay. What is Goldilocks zone?
Intermediary.
Huh?
Intermediate state.
क्या intermediate state?
Intermediate state जहाँ पे cold और वहाँ पे water liquid state
हाँ, क्या intermediate is?
बीच में ना solar
ज़्यादा ही बड़ा word use कर दिया intermediate zone. Simply put, okay, that area of a star, जहाँ पे temperature is just right, okay, and so water is able to remain liquid. So not too hot, not too cold. And what is the Earth? It's a Goldilocks zone. Earth खुद ब खुद एक Goldilocks zone है, पूरा Earth. Okay, so we are located just right when it comes to proximity with the sun. Okay, so ज़्यादा करीब भी नहीं है, ज़्यादा दूर भी नहीं है, so our water can remain liquid. Pluto's largest moon is Charon. Okay, I don't know why sir has asked me to take an extra class. I mean, an extra 10 minutes. So I don't know what am I going to teach you for extra 10 minutes. If you have any more questions, you can ask. Already figured. Okay, if I ask you all to explain now, can you all explain? Kya nahi? Of course you can explain. The ones behind? If I ask you to explain, can you explain? Okay, so let's do now this new student. I think someone's going to come now. So we'll just have like a quiz. Okay, I'll ask you and you'll answer. Okay, basics. So just go through your notes, go through whatever you've written. What was the Kepler's law? Anybody? Okay, let's see if you remember. Don't flip through your page. Let's see, what do you remember? Kepler's law?
sun situated at one of the side
Foci, हाँ, ठीक है.
and less and
हाँ.
side. This is like that it sweeps out equal areas in equal amount of time. Spread out the area.
Correct. Okay. हाँ, वही. Okay, so semi-major axis, if you are going to double it, the time taken is going to be tripled. Okay, or was it the other way around? Square the time. Okay, the time is doubled if the semi-major axis is tripled. Okay, so that means further you go from the sun, the more time you take for revolution. Yeah, the more time you take to revolve around the sun. Okay. Okay, can anybody just tell me the different stages of a star? Evolution of a star? Uh-huh. Huh. Huh? क्या फ्यूजन वाला पार्ट? रेड जायंट के बाद क्या होता है? And then after that, okay, these guys know. What about तुम्हारा कोई question पिछले? Tell me the stages of a star. From the beginning. Nebula, okay. Protostar. টিনেজ ফেজটো কি হয় ষ্টাৰ এটাৰ মাজতে আডাল্টটো হোৱা নাই বাচ্চাও নহয় দে মাজতে আছে এইটো কি ফেজ কি হয় এইটো টিনেজ তো টি দিয়ে আৰম্ভ হয় what is it T-Tory stage correct okay T-Tory বুলি কয় এইটো T-Tory that's the teenage phase বুলি কবা মাজতে start to form হৈ আছে এতিয়া full then when it's reached its adult phase হেতু কোনটো হয় তাৰ মাজত আৰু এটা আছে আমাৰ সান যোনটো ষ্টেটত আছে এতিয়া okay that's your main sequence star okay it's in the adult phase right now after that as it begins to age yeah what is it running out of what is it losing fuel kya hai fuel what is the fuel hydrogen so right so it's beginning to lose hydrogen so fusion komibole goi ase fusion komile there's lesser heat and so it's beginning to look reddish okay going to look reddish in color after that what happens as it ages further it's going to go back to a white dwarf stage it's going to implode okay implosion hoy all the materials will collapse and again when it collapses remember again a lot of heat is generated which is why it will begin to have a whitish color again because of the high temperature again the whole stage is going to be it's going to start jyoti mass is much higher than Chandrasekhar limit what's going to happen supernova explosion and then what is formed black hole or neutron okay a smaller star may be formed which you call a neutron okay you guys take a break okay just go through I'll go and ask if a new student is coming or not Ma'am, ahibone goi gol amar hoi gol sir wo student आपने जो
सॉरी क्या बोल रहा?
हो गया बोला सर, आपने बोला जो न्यू स्टूडेंट आएगा वो
वो तो अंदर ही बैठा है ना,
कब आया सर?
अंदर ही बैठा है।
रातिपुवा हिस्से मैं दिखाई दिसो
नहीं,
ओ
दिखाने की जरूरत नहीं है, हो जाएगा। आपका क्या कटेगा?
हाँ?
क्या कटेगा?
कौन सा ये लो
आपको पैसा डलवाने में क्या करोगे?
नो वो सर सर्विस लगता है
किसमें?
उस दिन वो मैसेज आया था एक मतलब वो ट्रांजेक्शन करने के लिए सर्विस लगता है। ओके नो वे डन for the day.